Good evening, Doctor. Good evening, Doctor. I've come to present a research project for my master's program entitled Explainable Cloud Forensics for Virtual Machines in Heterogeneous Distributed Data Centers. That's the content. So cloud computing is the delivery of cloud computing services over the internet. It's 90% of the businesses have embraced cloud computing services. As you can see from the statistics here, cloud computing, this graph here shows the cloud market share, or the companies that offer cloud computing services, how dominant are they? Amazon Web Services is it's the dominant company that in terms of provision and provision of cloud computing services, followed by Google Cloud, followed by Microsoft Azure. And this graph here shows the cloud data center growth as of from the year 2023 to 2033. And it's projected by the end of 2033, the cloud data center market growth will reach up to $69.45. And then this other graph here shows the cloud security incidents that have happened as the year 2024. Cloud computing and visualization. For a cloud service provider to deliver cloud computing services, he must do what you call virtualization of those resources or services or applications. Virtualization is the process of creating multiple virtual instances of physical resources or application resources. Application resources are being virtualized using the application virtualization software. For example, Microsoft applications are being virtualized using Microsoft App V, and Microsoft App V allows for the creation of multiple instances of those applications so that they can be delivered or deployed to the public cloud for user access. Then a hypervisor, it is a program that is used to virtualize the real hardware. So you can virtualize a CPU to form multiple instances of virtual CPUs. You can also virtualize, for example, a hard disk, and you form very many virtualized instances of a hard disk. Now, this diagram here shows 5 VMs being created on top of a Windows 11 host operating system or running on a VMware hypervisor. Now, once these VMs are created, multiple operating system, each VM will run its own application, isolated from each other. So once they are deployed in the cloud, that's when the users will access the VM and perform their day-to-day computational tasks. So the whole of this environment here is called the cloud computing environment. So these are the various types of virtualization, and this is the virtualization architecture. I mean the cloud computing architecture. So at the bottom here, there is the cloud service provider on-premise data center. Now the hardware components or the applications here are being virtualized using this virtualization layer, using the various virtualization software. And then at the cloud computing layer here, this is where the services are being delivered to the end users for them to use. Data centers. A data center is a facility that is made up of the three components of the computer, network, and storage, mandated to store large and enormous volumes of data and provide cloud computing services to the end users. Now, once these components, the primary components of the components, are dispersed in various geographical locations, they form what we call a distributed data center. This is a visualization that shows the various data centers, distributed data centers in various locations for MTN Uganda. These data centers are being distributed in order to provide you, the end users, with the services with no time lag. so that the services are brought near to the people. Heterogeneous data centers. These are data centers that consist of diverse, multiple, different computational resources and services that is aimed to accommodate a wide range of workloads and different user needs. As for example here, users in Lila are being provided with a private cloud with these services here, and infrastructure as a service, GPU, CPU, VMs, and software as a service. These different services or different software applications or different software, Google Meet, and so on. So this shows a visualization that can really try so that you can really identify or explain or a heterogeneous distributed data center. Cloud forensics, it's a term borrowed from digital forensics, but it is used to identify, preserve, analyze, collect, and report and present cloud security incidents that have happened in a cloud computing environment. Now, incidents that have happened in a cloud forensics environment. Now, these incidents can be analyzed or detected or identified using traditional cloud forensics methods like signature-based. However, these methods are slow at detecting evidence. For example, the forensics toolkit is slow at detecting evidence within the cloud environment. So, because of those the problems, because we can see other problems can be they lack explainability, they have high false positive rate, and then they cannot bypass the virtualized layers of abstraction. And also these ones, they cannot really extract the data from the VMs or the cloud platforms that are geographically distant from one another. So they suffer from that problem of extracting evidence and analyzing it from the clouds, private clouds or public clouds that are geographically distant from one another. Problem statements. Cloud service providers provide a wide range of cloud computing services. Among the cloud computing services provided, VMs are among the cloud computing services provided under infrastructure as a service. Now, once these VMs are deployed in the cloud, they can be compromised by cyber attackers. Once they are compromised, retrieving or extracting or analyzing evidence using the traditional forensic methods we saw, it is really a great challenge because of the fact that these methods are slow, manual, and they struggle at detecting new patterns of threats. For example, as we visualized, the signature and the rule-based detection methods or investigative methods, they only rely on the database of known threats. So they face that problem, and they cannot bypass the virtualized layers of abstraction, consisting of duplication, multi-tenancy, and many more. We need to develop a deep learning framework that can be used by forensic investigators to analyze forensics data and extract crime-related evidence from the virtual machines that are deployed in the cloud within the heterogeneous distributed data centers with the help of explainable artificial intelligence. So these are some of the specific objectives: detect, identify the status of the VM instances, identify important features needed by forensic analysts for evidence detection in the VM instances, build, train, and evaluate deep learning models for crime detection from the VM instances, from the data generated from the VM instances, and then incorporate explainable AI using Lime and Sharp. Significance of the study: the framework will be useful and used by crime by cybercrime investigators, detect or analyze evidence with a high true false positive rate, which is important in coming up with a comprehensive analytic report that can be administered or admissible in the courts of law. Then the framework will help stakeholders to respond to both insider and outsider attacks or threats. Then the framework will be of importance. It will enable organizations to build stronger security systems and defense mechanisms that will block such similar incidents in the future. These are some of the related works. Methodology. This is the methodology. These are the models I'm going to build. Feed-forward neural network, convolutional network, recurrent network, LSTM. This is the architecture of the neural networks that will be built, and LSTM will be built on two layers. The input layer having 50 neurons, the out layer having 1 neuron. You shall be using a sigmoid activation function for binary classification. Model building. These are the models we shall build, and we shall train them on 80% training dataset and 20% training dataset. Across 50 epochs, then evaluation matrices, those are the evaluation matrices we shall use, and then we shall incorporate artificial intelligence so that we can visualize key important features that are responsible for model. Some specific objectives, the methods, and those are with the references. Thank you for your kind attention. That's the end of my presentation.